Hey everyone, Nick Raboy here, and I'm going to be showing you how to create a very simple game using Angular and Socket.io. So when I say game, I am less emphasizing the fact that this is going to be an entertaining or even competitive game, but I'm more emphasizing on the fact that it's going to be an interactive kind of multiplayer experience to show you that, hey, multiple Angular clients can control this 2D element on the screen through Socket.io, so through event-based socket programming. So we're going to see this from scratch. I do have my editor up. I have my terminal up. What we need to do is we need to create both an Angular front-end client and a Node.js back-end client or server. So we'll actually start with the Angular side of things and work our way into the server side of things, and then we'll see it all in action using our web browser. So the first step is create a directory somewhere on your computer. We're going to create both the server project as well as the Angular project there. But I'm going to create the Angular project first. This assumes that you have the Angular CLI. So say ng new, and I'm going to say, we can go ahead and say maybe client. It's going to ask you a series of questions. Just go ahead and choose the defaults for them. So no to the router, and then just use CSS. They're not really going to be too relevant for this example. All right, so after it's installed, we won't worry about the Socket.io stuff yet, but we will. Let's go ahead and open up that client directory that was created, and we want to make changes to files inside the source and then app directory. So again, we won't be using any kind of router or anything like this. We won't be creating our own custom components. We're more or less going to edit what's already available to us based on the generated template that Angular provides. So let's start by opening up the app component HTML file. And let's clear that file. We're going to add our own code. So this game is going to be a true HTML kind of 2D game. So we're not just going to do something hacky. We're actually going to use the HTML canvas. So let's go ahead and add a canvas component, and we're going to style it. We're going to give it a width of maybe 640, a height of let's go ahead and say 480. And then let's go ahead and add a border around it so that way we know what's officially the canvas and what isn't. So we have our canvas. What we also want to do is we want to add a few buttons to this. So the buttons, we're not going to use keyboard listeners or anything like that. We're just going to use buttons to decide how our interaction with the game actually happens. So let's go ahead and maybe add some paragraph tags, and we're going to add some buttons. So I'm going to say button. Let's say this is a right button. Let's copy this line a few more times. Let's go ahead and say we have a left button. We're going to keep it very simple because the idea is not to make a complicated game. We're just creating a game that we can interact with other users using Angular and Socket.io. So I have our buttons. There's one more thing that we need to do. So with Angular, it's never advisable to access the DOM directly, so it's never advisable to try to access this canvas component or the buttons directly. Instead, what we want to do is we want to create a reference variable. So we can do that by using the hashtag or the pound symbol or whatever you want to call it, and then name this variable. So I'm going to name it game. Doesn't really matter what you call it. Just remember what it is so that way we can use it in our TypeScript. Now that we have the HTML component out of the way, at least for now, we're gonna come back into it. Let's go ahead and open up our TypeScript that pairs with this particular HTML file. And first of all, I'm gonna clean it up a bit so that way it matches the tab structure that I have for my editor. Makes it a little easier to read. But what we want to do is, well, first remove this title. It's not going to be relevant to us. We want to import a few classes or a few components into Angular. Let's start adding them now. So first of all, we have our component. What we also want is the on init. So we want to be able to manage those lifecycle events that Angular offers us. We're also going to want the view child, so that way we can access that reference variable from the HTML. And we want element ref because we want to be able to access what resides inside of that reference variable. So now that we have that, we can actually start creating our ng on init, which is going to be part of what we imported on line 1. So we can implement it. So implements on init. We'll have to create our public method, ng on init. We'll leave it blank for now. We're also going to have one more. We're going to have public ng after view init. And the reason why we have both is, well, one, inside the ng on init, we're actually going to establish the connection to our socket server. And then in the ng after view init, after the actual HTML renders, then we can actually do interactions with our canvas. So since we're not going to worry about the socket server quite yet, we're going to worry about our canvas. So let's go ahead and make some modifications here. So first of all, let's go ahead and grab that reference variable. So we're going to use the view child. So we're going to say view child. So we're going to do an annotation. We called the view child game in the HTML. And let's go ahead and reference it to an actual variable now. And that's going to be of type element ref. We're also going to define a context, which is going to be for our canvas. So we're going to say private context. Let's just go ahead and say that that's any. And let's go ahead and load it. So we can do this in the ng after view init. If we do it in the ng on init, it's probably not going to go well because the view might not have rendered yet. So we definitely want to do it on line 20. So let's go ahead and say the following. We're going to say this.context equals this.game canvas, which is our reference variable. We're going to say .native element, and then we're going to say .get context. So get context is an actual function that exists as part of the canvas. So if we were using vanilla JavaScript, that function would still exist. And we're going to say 2D. So this is going to be a 2D canvas. Now, if we wanted to, we could render a rectangle. Let's go ahead and render it now. We're gonna make some major modifications, I guess you can say, coming up. But let's go ahead and add a rectangle. Let's go ahead and say this.context.fillRect, so rectangle. Let's go ahead and position it at 20x, 20y, and give it a width of 20 and a height of 20. And save it. So let's go ahead and see what we have now and see what we need to do to make this interactive. So let's go ahead and run it. So I'm going to say ng serve. So I'm not in the correct path, so let's go ahead and go into the client path. I'm going to say ng serve. Now if I go to my web browser, we should be able to access it. So if we want, we can go to localhost, and that should be on port 4200 for Angular. And if you look, we do actually have our let me make this 100%. We actually do have our canvas. It's separated by a black border. We have a square which we rendered, and we have our buttons. But nothing happens. They don't do anything. We just have a game aspect of it ready to go. So this is where we're going to get more into the Socket.io stuff. And to do that, we're going to need to build our Socket.io server first. And to kind of give you some context here, so when it comes to game development, this doesn't apply to all game development, but generally when it comes to online games, you don't want the client to be in charge of keeping track of position information, because then you might have those malicious users that might say, hey, I am at this position, but I'm really not, or I have this amount of items, but I really don't. You want the server to be able to decide what clients should and should not be able to do. So that's more or less what's going to happen. We're gonna make requests to the server. The server is going to do certain things, and then we're going to get responses. We're never going to send requests. So let's kind of separate make requests versus send requests. So let's go ahead and open up our code. So let's go ahead and I'm in my Finder or my Explorer. So what I'm going to do is actually I'm going to open up another terminal. So if you're using Visual Studio Code, you can just do a split pane. Let's go ahead and go back a directory. Just open up a terminal however you see fit. What I want to do is I want to create a new folder. So I'm going to say make directory. I'm going to call it server. I'm going to navigate into it, and I'm going to say npm init -y. That'll create my package.json file. What I want to do now is I want to say npm install. I'm going to install Socket.io. I'm also going to install Express because it is a requirement, and I'm going to save it to my package.json file. I'm going to do one more thing here. I'm going to install, this isn't a required dependency, but it does make development a little easier. I'm going to install NodeMon, so I'm going to say npm install NodeMon, and this is going to be a development dependency. And all it does is it just hot reloads your application every time you hit the save key, or every time something changes within your project. All right, the final step here is we need an actual file to hold our code, so I'm going to say touch app.js. It'll create an app.js file. If you're using Windows or some operating system that doesn't support touch, just go ahead and create that app.js file, however makes the most sense to you. So before we actually add our code, let's go ahead and set up NodeMon. Again, this isn't a requirement. It's just to make our lives a little easier. Inside the package.json file, I'm going to add a new script. I'm going to call it start. And I'm going to say NodeMon, and I'm going to tell NodeMon to watch the app.js file for changes. And I can just exit out of that. Now what I want to do is inside my terminal, so that way I can just ignore the terminal going forward, is I'm going to say npm run start, which is the name of our script. And now what we have is we have on the left, I have my Angular application being served, and on the right, I have my Node.js application being served. So what I'm going to do is I'm going to kind of minimize this client. I'm going to open up the app.js file, and I'm going to hide my Explorer because really we're only touching these three files. App.js being the server-side code, and then app component, HTML and TS for TypeScript being the Angular code. So let's go ahead and start by adding imports to each of the dependencies that we just downloaded. So I'm going to say constant express equals require express. And I'm going to initialize it with the constructor parentheses. I'm going to say constant HTTP equals require HTTP, and we didn't need to download it because it's already a part of Express or a part of Node.js. But we're going to say server express, and then finally we're going to say constant socket.io equals require socket.io, and then we're going to pass in HTTP. So socket.io is going to do all of the communication with our sockets. Express is just going to serve that WebSocket or that socket server for us. So we have the imports done. Let's go ahead and start serving. Let's go ahead and say http.listen. We're going to say let's listen on port 3000. And upon success, let's go ahead and print out a message so that way we know it's working. Let's go ahead and say console.log. Let's go ahead and say listening at port 3000. Not a requirement, but it does help, especially if there's a problem. It'll be easier for us to troubleshoot. So we have the boilerplate added. Now this is a simple game, nothing too fancy here. We're basically going to allow multiple Angular clients to move that square around on the screen. Like I said, they're never going to be able to define the position, but they will be able to make requests. So the server is going to maintain the position, so we need to create a variable for that. So we're going to say variable position equals, and this is going to be an object. We'll say x is 200, maybe y is 200, and typically this would probably be part of a database. But we're not going to worry about a database for this example. So we're just going to store it in memory. When the server stops running, this will be refreshed. So it's just all in memory. Now let's start working with socket.io. This is where things get interesting. It's actually not difficult to use. But let's go ahead and say socket.io because that's what we called it on line 3. We're going to say on, so we're going to listen. We're going to listen for a special event. The connection event is actually a reserved event by socket.io. This event is triggered every time a new socket connects to this server. So when a socket connects, we're going to have information about that particular socket. And in this case, when they connect, well, maybe we want to share the position information with them. So I'm going to say socket.emit, and I'm going to say, you know what, I'm going to send a new event. I'm going to call it whatever I want as long as it's not a reserved event. I'm going to call it position, and I'm going to say position. So position being what we have on line 5. So that's what we're going to send to the user after they've connected. And what we can do is let's actually make use of this inside of our Angular code now. So this we have currently enough to go off of for Angular, because when we establish a connection, it'll now change our position to 200 by 200. So let's go back into our TypeScript code. We're going to go actually, I'm going to stop my Angular application. We do need a dependency. What I'm going to do is I'm going to install socket.io. We need the socket.io client for this. So we're going to say npm install. We're going to say socket.io, and we're going to say -- save. So socket.io is installed for both the server and the client in this case. All right, with that installed, let's go ahead and rerun our application so that way it's just serving in the background. Let's import that dependency. We're gonna, again, we're gonna stay inside of our app component.ts file, but we're gonna say import. We're gonna call it io from. We're gonna say socket.io, but this time around it's gonna be client, not just socket.io. So this will allow us to work with socket.io. What we want to define as far as variables is we want to have another variable here. Let's go ahead and say private socket, so that way we can use this socket variable throughout our component. And then inside of the ng on init, we probably want to establish a connection. So on line 18, let's say this.socket equals IO, and let's provide the information for our server. Our server being localhost port 3000. So ng on init will fire first. It'll connect, and then after the view renders, which will happen after the ng on init, we'll draw this. But actually now we're actually getting the position information from the server, so we're not relying on this locally. So let's make a modification here. So after we have the context, let's go ahead and listen for events. So we're going to say this.socket.on. So just like with the node code, we're going to listen for the position event, because remember, the server just emitted a position to all of the, well, not all, but this particular connected client. And I'll get more into that in just a second. But we have data. We could easily call it position if we wanted to. And let's go ahead and figure out what happens when position is heard. So let's move line 26 into there. So we have the position. It was sent through. So let's make an update here. Let's go ahead and say position.x and position.y. And we'll keep the size of the object. The size of the object is kind of irrelevant to the rest of our game, but the position is what we're concerned about. But we do need to make a change. So when it comes to the HTML canvas, every time something is rendered to the screen, it doesn't automatically refresh. So if this were to move around, if this rectangle were moving, it would basically draw kind of like a line or a streak, because the screen doesn't clear every render. So we have to do that manually. So let's go ahead and clear the screen. We can do this by doing the following. We can say this.context.clear rect. Instead of fill rect, it's clear rect. And it'll have four positions again, or four variables. We're going to have 0 being the y or the x, 0 being the y, and then we have a width and we have a height. So we're going to say this.gameCanvas.nativeElement.width, and then we're going to do the same thing for the height. We're going to say this.gameCanvas.nativeElement.height. So this will clear the screen every time some kind of position is received, and then we'll render this new square at the new location. So let's go ahead and look at our web browser, see if anything happened. You can see that the square, it's no longer in the corner of the screen. It's now at 200 by 200, which is good. So let's keep adding. Let's keep adding to our code. So now what we want to do is, well, we want to move around. We want to click those buttons. We want to send requests to change the position of this particular square. And we can do that through the following. Let's add another method to this particular TypeScript file. Let's go ahead and call it move. And let's go ahead and say that it accepts a direction. So what direction we want them to move. And this is going to be a string. And when this is called, we're going to say this.socket.emit. So just like we saw with Node, we're going to define an event that's not a reserved event. So we'll call it move. We can call it really whatever we want almost. And then we're going to pass the direction as our message for that event and save it. We'll go back into the HTML because we want to call this move. So we'll go back into the HTML file for Angular, and we'll edit our buttons. So now we have click event on our buttons. So we'll say move. And for this one, we'll pass right. We'll kind of do the same thing for all of them. I'm just going to copy this line, and we'll change it in a second. So we have left, we have up, and we have down. So remember, we're calling this move method that we just created, and we're passing this string. And then the server is going to figure out what to do with that. So let's go back into our server now. We're going to go into the app.js file, and we're going to add a line after line 11. So this is where we're now have access to this particular socket, and we're listening for messages sent from this socket. So we're going to say socket.on. We're listening for move events, and we're going to handle the data appropriately that comes in with that move event. So we can do a switch statement or an if statement or whatever you really want. We're going to say data, and we're going to say if it was left was the data, then we can do the following. Let's say position.x. We can say equals position.x minus 5. We can say socket.io.emit position, and I'm going to explain this in a second. And we're going to return the position, and then we're going to break. So let me explain this. So we're changing the position. We're subtracting 5 from the position. We're calling socket.io emit this time. So when we called socket emit, it sent the message only to that particular socket. It used the position event. When we call socket.io emit, we're sending it to all connected clients. So all connected Angular clients. We're still using the position event, but it's being sent to everyone this time. So let's follow up with the rest of our possible directions. So we have right. So right is going to be plus 5 on the x. We have up, which is going to be y minus 5, right? And then we have down, which is going to be y plus 5. And you could probably better optimize this, but this is just an example. So our server should be good. So let's go back into our code now. Let's check it out. Or actually, let's go back into our Chrome. So I'm going to refresh it. I'm going to push these buttons and see it move around. So right, left, down, everything seems good. So now let's put it to the real test. Let's open up another web browser and see if it's truly interactive with all clients. So I'll go to localhost 4200. I do have it on both windows, and I'm going to hit down, up, left, right. Everything seems to be good, which is good. So these clients, they don't have to be on my same computer, but for any web browser I open that has this Angular application, it's going to be treated as a separate client for our server, and our server is going to broadcast the game information to all of our clients now. So this was a pretty cool example. I think it's a little better than the basic chat example that you get with Socket.io, because I personally find this a little bit more interesting. But you just saw how to use Socket.io with Angular and Node. And this can be carried across pretty much any kind of front-end framework. You could use Vue, React. Socket.io even provides Java libraries for Android. There's a lot of great things that you can accomplish with it.